Okay, Algebra 2, we're going to do a function recap. So let's talk about this. So here's our function recap. This really sets it out nicely and explains it really nicely. So if you were to evaluate f of x plus 1, given that f of x equals x squared minus 3x, okay, you might be like, where do I even begin? So what it's saying is you're given this equation. So you write the original equation, you write in the original given the function here. F of x equals x squared minus 3x. Then you're going to replace all of the x's with some sort of placeholder. And here it just shows you like that, but I like to make mine bigger. So if you notice, this was originally x squared, f of x equals that. You're going to replace this, so if I'm going to do it kind of big, I'm going to do it big. Go big or go home, like this. So I know something else is going to be going in here. All right? Now, what they're telling us to do is evaluate it with this. This x plus 1 is going in these placeholders, okay, where these used to be. So I'm going to substitute the x plus 1 everywhere that those were, if you notice. Then you just simplify. This is evaluating f of x plus 1 equals, and now you've got, you FOIL this, so x squared plus 2x plus 1 plus 3x plus 3. I've distributed this. And then we come up. So basically f of x plus 1 equals this. All right? Hopefully that helps. Now, determining the domain of a function. These are there are only two things that run interference with the domain, okay? One is dividing by 0, that's a big no-no. And the second is taking the square root of a negative number. That's a big no-no, okay? And sometimes you're taking the square root of a number that can't be 0 or a negative number because it's in the denominator. So, like this one here. So it says state the domain. We're asked, what are the x values that we can plug into this function right here? What are the x values? Well, this is 3, I'm going to write it bigger because I can really see it, 3 over x squared minus 25. Well, I need to figure out what numbers are going to, since dividing by 0 is a no-no, what would make this 0? So you basically just set your denominator equal to 0, and then solve. So I'm going to take that. I'm going to say x squared minus 25 equals 0. There's many ways I can do this. I can do it by factoring this into x plus 5, x minus 5 equals 0, and then solving each one of x plus 5 equals 0, so x cannot equal negative 5. X minus 5 equals 0, so x cannot equal positive 5. Another way to do that would be and that's what's done right here, okay? We basically took this, factored it out, and determined that x equaling 5 or negative 5 is going to make this equation equal to 0, which we do not want. So, another way, of course, to do it would be to use your square root method. If you know how to do that, where you have this, you add 25 to both sides, and you get x squared equals 25, and then you take the square root of both sides, and you're left with the square root of 25, and that is plus or minus 5. Okay, so those are the two ways you can solve this specific one. The square root method doesn't always work if you have a trinomial. It only works if you have a perfect square binomial. So you're going to state your domain restrictions, meaning x cannot equal -5 or 5. All right. Now, a lot of you are having trouble with this interval notation. Please, please, please practice that. It is so important. So what this is saying is that x cannot be 5 or -5. So here is how you'd write it. If you do not know what this means, you need to get clarification on that, okay? Please, please practice your interval notation. The brackets mean include. The parentheses mean exclude. So what this is saying is -infinity up to -5. It does not include it because it's a parentheses. Or -5 to 5. Because all those numbers are fine as long as -5 and 5 are not included. And then 5 to infinity. Okay? So keep in mind that that's what that is. All right, I hope that helps. All right, so now let's flip to the back of this page and keep going. We are going to, I might turn some light on here. Hopefully that will help. We've got h of x equals the square root of -2x. So now we've got a square root here. So we know that this has to be a positive number, right? So you write the original equation. What are the restrictions? In this case, is x in the denominator? No. So we don't care if x is equal to, if this is equal to 0, because you can take the square root of 0. But we cannot take the square root of a negative number. So whatever this is has to be greater than or equal to 0. So you take what's inside of your square root, you set it greater than or equal to 0, and then you solve it. Yay! So I'm going to subtract 9 from both sides. I get -2x greater than or equal to -9. And then I'm going to divide by -2, and you know when you divide or multiply by a negative, you've got to flip that sign. Flip that sign. All right? And so there you go. These are your domain restrictions. X has to be less than or equal to 9/2. As long as x is less than or equal to 9/2, then you're good. How do you write that in interval notation? Well, it has to be less than, so your very lowest number, right? In interval notation, your lowest goes here, your highest goes here. And then you use either the brackets or the parentheses to determine include or exclude. So the domain is restricted to all numbers less than or equal to 9/2. And this very last one, g of t is equal to the absolute value of 4 minus t. Write the original equation, determine any restrictions on value. Do we have any domain restrictions in the sense that, is there a radical? Is there a radical? Actually, is x in a radical, right? Is an unknown number in a radical? Or is x in the denominator? If both of those, oh, I didn't even spell that right, denominator, is x inside the radical? No. Is x in the denominator? No. So then there's no domain restrictions. No restrictions. All right. So then the domain is all real numbers. All right. So then your interval notation, your very lowest is going to be -infinity. Your very highest is going to be +infinity. All right. Hope that helps. Bye, guys.